Thanks for tuning in today. Today I'll be talking about nodes. I'm your host, Nathan Patnam, and let's get started. So today we're going to be talking about what nodes are and how we can use them like building blocks to build bigger data structures, and then we're going to implement the node class in Python. So what exactly is a node? I like to think of a node kind of like a Lego piece. A Lego individual piece, like you see on the left-hand side, it's not really that great by itself, but when you put them together, you can create these great structures, in this case, like the Superman Lego piece from all those smaller Lego pieces. And so basically what a node is a data structure that usually holds one item, and so knows has some type of value, and it knows about the node that comes after it. So what does a node know about itself? Like I said, it knows usually its value, and it usually knows the node that comes after it. And so what happens in the case if a node is by itself or doesn't have anything connected to it? So an example in our Q class that we implemented 2 days ago, where we implemented using nodes, there was a special edge case we had to worry about when we were adding a node to an empty list. And so in that case scenario, if a node is by itself in the queue, then there's really nothing else that comes after it. And so we have to set that to either null or none. And since we're using Python, what we're going to be doing is that when we create a node, and since the node doesn't know the thing that comes after it from the start, we'll be setting that to none. And so in some cases, when we're using nodes to build these bigger data structures, one data structure is a doubly linked list that we can implement using nodes. And in that case, that's one of the few cases where a node knows the thing that comes after it and also knows about the node that comes before it. And so in the case like before, if a node's by itself, then we'll set the node before and the node after both to be none. And then we can just use that same logic for other cases, like if there's 2 items and you're talking about the first item in the data structure, the thing before it would be none, and the second item in the data structure, the thing that'll be after will be none, since there's only 2 items in it. And so, sure. Now, some of those data structures that we can build using nodes include linked lists, queues, stacks, and decks. I've already implemented queues and stacks using nodes, so you can look at my previous videos if you want to see that. And then trees also. We haven't talked about trees, and that's another subject we'll cover on another day. It's a bit of a hefty subject, and we can implement trees using nodes. So let's get started by implementing the node class in Python. So I'm just going to go and slide over to my code editor, which is Visual Studio Code. And so basically what I'm going to do is I'm going to delete all this code that I wrote beforehand because I want to be able to code this in real time to show you what my mindset is and why I'm doing things the way that I'm doing. So the first thing I'm going to do is I'm going to show you the unit test that we have written. So basically we have the setup which will be run before every unit test runs, and that creates a new node called our node. So the first unit test is making sure we're able to get the data from this node. Second test is making sure that we're able to set the data in a node. The third test is making sure that we're able to get the next node from a node, and we're checking the case when a node by itself, and we want to make sure that the next node we're getting is none, since that's what we're going to be using to implement it. And the last case is when we actually set it to a real value, when we create another node and have our node that we created at the very beginning, have its next node be this new node, and being able to retrieve that back. So if we run our unit tests, let me first go into the right directory. You'll see that 3 of them fail. The third unit test gets set next node from tail is passing because in our case, none is just implied, but we're going to actually explicitly show it in our node class. So when we create a node, and since we're using it just for the class itself, the node will know 2 things, its value and the node that comes after it. And then I can show you later on in another video when we implement the doubly linked list, one node is going to have 3 class variables and also know about the node that comes before it. So we'll do something like self.value equals value, and we'll do something like self.next node, or self.next, we should say, equals none. And then get data is just simply these 4 methods right here, just simply getting and setting methods, so they're pretty easy to implement. So we'll just do return self.value. Let's see how many unit tests we're passing now. We're passing 2 unit tests. We're still failing 2. We'll do self.value equals value, since we're just setting the class variable with a set data method. Now we're failing just 1 unit test, and then we'll say self.next equals, or we'll say return self.next. And then we'll say self.next equals node. So let me go into a little more detail about what self.next really is. So our nodes don't really know exactly about the node that comes after it, they're pointing to it. So there's this concept called a pointer. And so let me just kind of show you with a pretty uh, simple picture. Say I had two nodes, a node that had a value of 1 and a node that had a value of 4. And let's say that a node knows about the node that comes after it. Let's say 1 knows about the node 4 and it comes after it. So if I were to do something like use the get next node method on this 1, I would get back 4. And so the idea here is that this arrow is a pointer. So the node 1 doesn't know directly about node 4. It's simply when I call the get next node, it will point to the memory location that this 4 is in my computer, and it'll retrieve that back for me. And that's kind of what a pointer is. Pointers are a tricky subject, and you see them a lot in C++. And I can go and talk more about it in a separate video. If you want me to, just comment down below. But the last thing I need to do is just show you guys that when I run my unit tests, they're all passing. So that's the node class. I'll show you the Q class that we implemented earlier and how that uses nodes to help build it. And so in our case, we have two classes, a node and queue class. So say, for example, we're talking about the queue method, which is the way of adding items to a queue. We're creating a node here, and then we're setting the next node of that node to be the new node, and we're doing things like that. So yeah, that's basically about it when it comes to what nodes are and how we can use them like Lego blocks to create other data structures like queues. Thanks for tuning in. Comment down below what you want to see next, and thanks for watching. See you next time.